A 3D printed Geneva mechanism. Yeah, other people call it other names, but the basic idea is it goes round a quarter of a turn and then is locked into position by the fact that it's along this curve here. So this is locked now while this rotates. 3D printed very cleverly, but unfortunately the shaft, which is supposed to be done in one part, so we have what looks like basically a Lego brick along the bottom, a Technic brick with two gears, and then the shaft was supposed to come up through like this one, beautiful and neat, but unfortunately on this one it broke off, which is why I've got it, because it broke, and that's what I love, things that are broken that I can play with. So what did I do to repair it? Place the Lego piece through the middle. Here we can see the Lego piece going through the middle, and then got a piece of, I think it's 1/4 inch steel, drilled a hole in the bottom and tapped it, and then made it so that, if we can see it, I could put a screw through this Lego brick into it to hold this piece of rod in place, and then put a washer on so that when this cross piece goes on the top, can we do that? There we are. When that goes on the top, it's just the right height to go onto here. Unfortunately it didn't quite fit when I'd done that, so I had to just chamfer a bit off each of these legs. Having done that then, the thing seemed to work quite well. Next objective then, put a motor on it. I tried for a long time with a Lego motor, but couldn't work out how to fasten onto this piece securely and secure the motor on the end. So I gave up and went for one of these little lock motors, which I absolutely love and think are beautiful. But to get the Lego brick on the top then, it does just push on. Push on, but the shaft of the motor has a flat on it. Don't know if we can see that just there. So what I do is to put some solder on, use a torch very carefully on the end, put some solder along the side of the flat, and then shape it so that it goes into the little square there. Suppose it could be done with a bit of araldite, some sort of glue, or some epoxy putty. That would probably do exactly the same job. But anyway, that's the way it sort of works. I reckon the motor that I've used is something like 600:1. You can get these gearboxes, these motors with all sorts of gear ratios, but I think I've used the 600:1. That then is clamped onto this piece of plastic, which just clamps onto bolted onto the Lego brick, and then what I've done is to bolt the motor onto the end with another piece of plastic, so it's sort of sandwiched. Suspect that maybe a bit of araldite or something like that, epoxy putty, might make it a bit more secure, but it seems to work okay. So it'll stand up. I just put this bit, which happens to be off some shelves, onto it, bolted that on, and then it'll stand up. Wanted to use it using a old vape cell, which of course I have put protection on. I assume these are quite dangerous without protection, so I put a protection circuit board onto it. I then wanted a timer, so I went back to my old favourite, the 555 timer, but the problem being that with a normal 555 timer, the lithium cell didn't seem to want to work, so I went for a CMOS, and instead of a 5-volt relay, a 3-volt relay. The relay is only there so that I don't have any connection to the battery or the cell when it's not working. So the principal idea is, if we can see this, then we have our cell connected on here, which comes in. It only should go to the relay, but when I started using the CMOS timer, I found that it couldn't drive the relay, so I had to put a transistor in there to drive the relay. Unfortunately, I connected the transistor to the positive again, which I didn't want to do. Where have we gone? I just wanted the positive to come to the relay contact and only be energized when I wanted it to rotate. This is just a standard sort of 555 circuit. We have here a trigger so that pin 2 is triggered when the positive comes onto this switched positive, the orange. Then it triggers the 555. The 555 is triggered. It's got the power because it's pressed across here, so it's got power into it. That starts it going. It going then is in monostable mode, so that switches on the transistor, which switches on the relay. Once the relay is switched on, that's the red goes up onto the switched positive, then that holds the 555 on for its duration of its monostable, which is determined by this variable resistor here and this 100 microfarad capacitor here. I've also put on an LED so that we can see when it's on. So yeah, that's the circuit board. This is sort of the layout that I've used, which is Vero, but this is the original one with the diode going from the output to the relay. And as I say, I've replaced that with the transistor. So a resistor to the transistor base, and then the collector goes to positive, and the emitter then comes down here to the relay. Don't like that particular part about it. Would much rather redesign it and use the transistor to connect to the negative side of the relay rather than the positive. But I'll have to look into that and see how it'll work. So yeah, that's my mechanism as given to me, and by pressing the button then set it to go for a certain length of time, and then it stops. Now all I need to do now is find something to use it for. Can't sort of think how I could build it into some sort of model, but I'm very pleased with it as it is. Given me a great deal of pleasure in doing it. So that's my Geneva mechanism, 3D printed. Yeah, so if you want to find where this is, type into your search engine 3D printed Geneva and put Lego on the end, and it will throw you this one up. There seem to be hundreds of others, but this one seems very nice, exactly the sort of thing that I've wanted to build for a long time. So it's bye now, bye.